About 3 years ago, I had uploaded this video. Please don't watch this video and trust me, it's really boring. Today, I am going to extend the topic and share with you the states of matter in detail. Do you know how many states of matter exist? If your answer is 3, 4 or 5, you are wrong. There are 22 states of matter.
मस्त जोक मारा रे या हंस रे हलकट हंस
No, I'm not joking. Let's see how. So, let's start from the basics. What is matter? Well, anything that has mass and occupies space is called matter. But how does the state of matter come into existence? The state of matter is determined by the energy and entropy in the atoms and molecules of the object. I would come with a video explaining about entropy very soon in the future. For now, know that entropy is a measure of disorderliness of the atoms of a substance. When you heat ice and it becomes water, the entropy of the atoms increases according to the second law of thermodynamics. Wait a second, can't I cool down the water and the entropy would decrease? Isn't this a violation of the law? Well, not exactly. In the process of cooling the water, we need some external energy too, right? And that energy balances the decrease in entropy, and in overall the entropy increases. A scientist named William Crookes was thinking of increasing the entropy even of the gaseous state. So, in 1879, he heated the gas until some changes would have been shown up. The gas was heated so much that the nucleus of the atoms ejected the electrons orbiting them. Even the proton and neutrons got separated, creating a highly excited state of matter called plasma. Plasma is commonly seen in lightning, auroras, welding arcs, and most importantly, the sun. The most abundant state of our universe is also plasma only. Before knowing the other states of matter, we need to clarify our concept. The state of matter doesn't only change with temperature, it changes with the change in one more factor, and that's pressure. Look at this diagram. If we keep the pressure constant and increase or decrease the temperature, the state changes and vice versa. So we can conclude that state changes with both the change in temperature and the change in pressure. Some people may be curious what could happen if we even heat the plasma and keep the pressure constant. And here's what you get, the quark-gluon plasma. In this state, the heat is so much that even the protons and neutrons melt and the strongly bonded quarks get separated. The binding particles of the quarks, that is the gluons, also melt. This state was formed during the Big Bang, but when the universe got cooler, the quarks and gluons joined together to form protons and neutrons. And in today's date, it's impossible to observe this state. If we do the opposite, we keep the temperature constant and increase the pressure, we will get a new state, degenerative matter. In this state, the pressure is so much that the electrons get separated from their respective atoms and start traveling at the speed of light. If the pressure continues to increase, the atoms would lose their atomic structure. Now, instead of keeping anything constant, let's increase the pressure and temperature together. We would get superionic ice. This ice is formed at the temperature of around 5,000 degrees Celsius and 2 million times the atmospheric pressure of the Earth. But how can ice exist at such a high temperature? Well, when we heat the normal ice, its atoms get separated and the entropy increases to get water. But in the superionic ice, the pressure is so much that the atoms don't get a chance to get separated and act as a fluid. And finally, the latest discovered state of matter, quantum spin liquid, but it has no connection with the liquid state. In normal states, when they are cooled down, their electrons get aligned. But in the case of this state, even at very cold temperatures, the electrons move freely. It was proposed in 1970 by the famous physicist and Nobel Prize winner Philip Warren Anderson. Its existence was proved in 2017. If you want to know more about the states of matter, you can read this Wikipedia page. Link in description. Thanks.